So yeah, thanks again for tuning in. This is episode 18, as I mentioned, and we're looking at sprinkler heads part 3. So obviously it is part 3, so if you haven't seen part 1 and 2 yet, then you can go back and see those. They are on our YouTube channel, and they're also on our website as well. So you can go back and see those. So sprinkler heads part 3 is basically trying to wrap up the subject and cover all the areas that I haven't looked at so far. I'm probably going to leave some bits. So if there's something that you think, okay, well, Andy, you haven't actually told me about this particular aspect of sprinkler heads, then yeah, let me know. Send me an email, put it in the chat, and I can always add it in at a later date. But for now, let's see what I've got planned for today. So we're going to start off by looking at a data sheet. So whenever you are purchasing or specifying, installing sprinkler heads, then, you know, for anything really, then obviously the data sheet is very important, particularly with sprinkler heads, because as we've already sort of covered in previous episodes, you know, there is a lot of options. You know, there's different manufacturers, different activation temperatures, they're different whether they're pendant or upright, they're different minimum operating temperatures, different threads, materials, finishes. You know, there is so much choice out there for sprinkler heads. So the data sheet becomes, you know, even more important really to make sure that you've got a head that you want, and also a head that is actually going to be compliant to the design and the kind of code standards that you are installing to. So let's have a look at a data sheet. As I say, each manufacturer will have a different way of laying out the information. This one, as you can see here, is a Viking data sheet. So in the top right-hand corner, we've got the model number and key information. So first of all, it says Micromatic. So that is, you can see after that, it just says registered. So that's obviously a kind of trade name that they're applying to their sprinkler technology. So we can really ignore that. It's a standard response head. So remember, we've got standard response and quick response heads. So this is a standard response head. It says pendant. So presumably that means that this head can only be installed in the pendant position. So again, if you wanted to install it in the upright position, then that's a no. Some heads can be installed in both the pendant and upright positions. But say this one is pendant specific, and that's all to do with the deflector plate and how the water is actually discharged when the water hits that deflector. So it's a pendant sprinkler, and then the model number is a VK102, and then it has the K factor there, 5.6 in brackets. Now maybe you're thinking 5.6, that's quite a small K factor. But just remember, there are imperial measurements and metric measurements. So that K 5.6 is basically an American measurement of K factor. So they're using different figures. They're using gallons per minute or second. We're using litres per minute. They're using pounds per square inch or pounds per square foot in terms of pressure, and you know, we're using bar for our pressure. So that's why the numbers vary. So 5.6 is written here, Viking. You know, that they're set up for the American market on their data sheet. The UK K factor is an 80.6, and that does say that in the information further on in the data sheet. We've got a picture of the product. But bear in mind that as we go through it, there are a load of different options in terms of finishings, etc. So, you know, just because the picture shows it in kind of an unfinished brass, that doesn't necessarily mean that is what you're going to get, because again, there's lots of different options there. So we've got the approvals. First of all, we've got the description. So yeah, you can read through that. Obviously, that just tells you what it is. Next is the approvals. I'll come on to that in more detail later on. So this particular head you can see has been approved by UL, FM, VDS, LPCB. It's also CE certified, and it's got a couple of other minor approvals as well, which is obviously all good. The more approvals it's got, the more versatile it is. If you've got different projects, different parts of the world, you can still use the same head. Further down, just going back on to the approvals. The LPCB is the UK body that's most used for approvals for this sort of thing in sprinkler world. They have something called the Red Book Live. So I'm pretty sure the web address is redbooklive.com, but it's something along those lines anyway. And that is like an online catalogue of all of the approved equipment. And I think it's rather good because, we don't know how old this data sheet is. It may well be that, you go online, you download a data sheet that you found, and actually the data sheet is 10 years old, and this head is no longer approved. So the way to check that is to say, go on to the Red Book Live, you type in the model number, and it should pop up, and you can check whether the approval status is still good. Other approval bodies do have similar systems, but for my money, they're actually not as user-friendly as the LPCB version. The LPCB version, the Red Book Live, seems to be very much set up for people just to kind of drop on, type it in, click, very, very quick. Doesn't ask you to sign up or kind of give you any kind of details. It's just basically just a live catalogue of products. So that's good to have a look at and check just to make sure that the approval is actually still valid. And also whether the approval has any sort of additional clauses. Again, sometimes the approvals will say, well, yeah, it is approved as long as these conditions are met. So again, sometimes it's good to kind of read the small print on the approvals, but some of that is covered in the data sheet later on. Then we've got some technical data. So minimum operating pressure, maximum working pressure. Again, that's pretty standard for me. 0.5 bar and 12 bar maximum working pressure. The thread. So again, sometimes you need to be careful between NPT and BSP thread. We use BSP here in the UK mostly. NPT again is the kind of American standard. Although I understand that 1/2 inch or 15 mil is the same, so they are kind of compatible for one to another. But it does depend on the different size of thread as to whether they're compatible or not. Nominal K factors, so we've covered, and then some materials that are used. So some sites are very particular about the materials that you use. I know I've been involved with projects, particularly for silicon, where they're looking to either eliminate silicon or reduce it right down. So yeah, having that information on the data sheet in terms of, this is exactly the materials that we're using for this, and then it can be very kind of clear cut as to whether it has this material in it or not. So as you can see, this data sheet is actually 7 pages long. So yeah, it's very detailed. But it is what it is really. So we've got various temperature ratings at the top there. That's also covered in a table coming up, and then we have mention of a sprinkler wrench. So sprinkler head manufacturers are very fussy about installation. This is obviously to stop the head from being damaged, and also that in terms of mechanically being damaged, and also the finish as well. So they want you to use specific wrenches. Obviously, when it gets on site, this specific wrench may not be used, but the manufacturer recommended that you use particular wrenches. So if you then say my sprinkler head is damaged or scuffed or whatever, then that's one of the things I'll be pointing out to you, is that, well, we said to use these particular wrenches, and there's some pictures coming up. So a few more bits there, obviously installation, operation, inspections, tests and maintenance, but I'm not going to kind of go through those. So here's an example of a sprinkler wrench, so kind of flat-faced wrench. We have some pictures of the protective clips that could be on the heads, so obviously they need to be removed at the point of commissioning or before. More details about the operation temperatures. Again, make sure you get the right head that you need. And then details of finishes and coatings. So you can see this one here is available in brass, in chrome, in white polyester, black polyester, and ENT. I'm not quite sure what ENT is, to be honest, but yeah, there's different options for what you want. Moving on still further, so we've got now specific approval. So this is quite important here because not every approval is applied to every single part of the sprinkler head. So it might be that you've got specific approvals which are for different finishes, or it might be to do with the, is it escutons? So I can never quite think how you say that word there, but the rosettes, the accessories that kind of go with it. Again, some are approved to be used with particular accessories and some are not. Some are approved for particular coverage and some are not. So, although that this head is approved, we do need to dig down in terms of what exactly it is approved to do. So we need to kind of refer carefully to this table and say also check out the approval certificate itself, just to make sure that the application that we're using this head for is covered under the approval that we want it to have. So again, all that information is very clear on the data sheet. There's another table here specifically for FM approval. So again, is kind of slightly different finishes, etc. And there's another one here for UL, VDS, and LPCB. So again, there's 3 pages of kind of specific approvals for this head, which I'll come on to later. But that's kind of why, really. Most sprinkler contractors, they have just a few sprinkler heads that they like to use, and mostly that's because they've studied the data sheet and they're absolutely happy that that's the one that they want, and then they obviously just keep on using it. We're going to save them the trouble of scrolling through data sheets to check particular approvals. They like to basically just have a few that they know work and they like, and they just keep on using them. More information about the temperatures there, finished and coated. Have I gone forwards or backwards? I think I might have gone a different way. Okay, here we go. Special wrenches. So again, we've got more information here. Again, different torque settings to be used. So again, sprinkler head manufacturers are quite fussy about how you actually install the heads in practice on site. Sprinkler engineers and fitters, they'll have their own technique of doing it, and obviously as long as it doesn't leak and it's not damaged, then happy days, really. Some more dimensions there, recommended distances from ceilings to deflectors, etc. So that is covered by the code standards as well in terms of minimum maximum distances, but obviously the manufacturer is also giving some instructions there as well. Particularly when, again, you've got different finishes, rosettes and escutons. Okay, I just want to go through a few tables with you. So first of all, table 19. We've looked at this already when we've looked at the laying out of sprinkler heads. So different hazard classes have different maximum areas per sprinkler. So this is called the coverage. And again, as I've already mentioned, light hazard. Yeah, don't worry about light hazard. Not a lot of buildings really are going to be light hazard these days. It's all either going to be ordinary hazard or high hazard. And again, in my world, ordinary hazard is where I spend sort of most of my time and efforts and energy, because ordinary hazard includes airports, hospitals, shopping centres, hotels, kind of smaller kind of factories and production. So yeah, where we sell our products, Project Fire is mostly into the ordinary hazard area, not into the high hazard. But you can see high hazard there. We have a smaller area per sprinkler, which means that we have more sprinkler heads per area, which means that we're increasing the discharge density, and that's what it's all about, really. Table 37A, again, is a key one for sprinkler heads. So it gives you the hazard class on the left, the design density. So you can see when it gets to high hazard process and high hazard storage, the design density may vary depending on what you're doing or what you're storing. And then we have some sprinkler head types. So it won't come as much of a surprise that for light hazard and ordinary hazard, essentially you can use whatever style of sprinkler head you like. Conventional, spray, ceiling mounted, flush mounted, flat spray, recessed, concealed and sidewall. Just again, so you might be surprised that concealed is on that list. So what that's basically saying is that the British standard doesn't mind concealed heads being used, but your problem is going to be in terms of getting one that is approved for use. Which again, I think we've spoken about in previous episodes to do with concealed sprinkler heads. We need them to be quick response, and if there's kind of lots of actions that are taking place, then often they are not classified as quick response. Quick response is required for life safety, and so although, say, the British standard will say that concealed is fine as far as they're concerned, often it isn't fine as far as meeting other parts of the codes are concerned and also getting an approval for it. But then when we get to high hazard process and high hazard storage, we're talking warehouses, we're talking factories, we want either conventional or spray, which again, it shouldn't be a surprise. We don't want to start messing around with sidewall heads, with flush mounted heads, recessed heads, concealed heads. We're just going to have the boring ones basically, because our focus is on getting the water discharged rather than any kind of aesthetic appeal. And then also finally on the table here, nominal K factor. So for light hazard, you can go down as low as 57. For ordinary hazard, it's 80 or 115. And these K factors here are so that the table methods of calculation will work. So we've got a maximum area per sprinkler, we've got maximum and minimum dimensions in terms of how the heads are laid out. We've got K factors there. We've got minimal sprinkler head pressure at each head. So basically, if you put all that together, and somebody somewhere in the past has sat down and kind of worked all this out, if you put all that together, you will get a compliant system, kind of automatically. The numbers just work. If you're going fully hydraulically calculated, then you can start to play about with kind of fine-tuning the system. But a table method, say, just involves following rule A, B, C, and D, and when you do that, you get a compliant system. And again, it shouldn't be no surprise really that as the risk goes up, that the K factor of the heads goes up, so that we can discharge more water. Table 38, again, it is telling you where you can use particular sprinkler heads in particular circumstances. So we've got standard response, special response, and quick response. I must admit, I don't know a great deal about special response. The code standards are telling me that they are in the middle of quick and standard. So I guess the concealed sprinkler heads may well be special response, i.e. they're better than standard response because they're using quick response heads, but they're not actually quick response. So I think I told you earlier that they were classed as fast response, so probably fast and special response are kind of interchangeable terms, but I'm not really sure, to be honest. Most of the time we're used to using quick response or standard response. So you can see from the table, again, in certain circumstances, you're allowed to use certain types and not in others. Again, that's good to refer to. Here's a bit of extra information for you as far as sprinklers in racks are concerned, which again is not something that we've spoken about much or in the past. But yeah, where you've got racking, depending on what you're storing, how high you're storing it, what the racks are like, are they open or are they kind of solid racks? There's loads of information in the standards about what to do in those particular circumstances. And in some cases, you want sprinklers in the rack. So basically, each shelf or every other shelf would have pipework and would have heads mounted in it. And there's a little note there to say that we don't want, well, the sprinklers in the ceiling shall have a sensitivity equal to or of slower response than the sprinklers situated in the racks. So what that means is what you don't want to happen is for the sprinkler heads in the ceiling to activate before the ones in the racks. Again, makes sense, doesn't it? If we got a fire, where's it going to be? It's going to be in the racks because that's where the flammable stuff is. So when that fire happens, we want the heads in the rack to operate first because they're closer to the fire and they're going to do the most efficient job of tackling the fire. If they can't handle it, and the fire continues to grow, then it's going to set off the heads at ceiling level to provide extra coverage. And that's the way round we want it. We don't want the heads in the ceiling trying to do the job to start with because they get the heads below them wet and get them cold, and so they don't operate. So that's what that note is all about there, to do with or the order in which you want heads to operate. Little note about sprinklers on a slope. So yes, we can install sprinklers on a slope. In fact, all sprinkler pipe work should be on a slope. Maybe I'll cover that in a future episode. But yeah, the idea is that you want to be able to drain your sprinkler system. And to do that, we need all of the pipes to be on a slight slope so that the water flows down to the nearest drain. Achieving that in practice is a nightmare, but that's the theory anyway, that all the pipes should be on a slight slope to a suitable drain location so that we can get all the water out. But also we can install the pipe work on a steeper slope where we've got a sloped ceiling, and that's true for warehouses, and that's also true for residential and domestic. Again, what you need to do is check the data sheet for the sprinkler head to see what its approval says. Often it will give a kind of a maximum angle that it can be installed to, and the code standards also may well give a maximum angle which is suitable. And that on the screen there is just a little note that the LPCB, our spacing is in the sort of the horizontal plane. Other code standards use the kind of the plane along the angle. We use just the horizontal distance, which personally I think is good, and that kind of keeps it simple really, because that's the important thing as far as water distribution is concerned. Rosettes, baffles, guards, and shields. So I've got a few examples here on the screen. So the ones on the left there, they are called rosettes. They are often used in offices, for example, places where you've got a ceiling void. You've got the heads poking through the ceiling in a pendant position. We can, of course, just drill a hole and put the sprinkler head in, but it looks nicer to have a what's called a rosette, which just covers the hole. It also hides any inconsistencies with where the hole has been drilled. So it gives you a little bit of tolerance in terms of drilling the hole. You can drill a sort of a larger hole to make sure that the head locates with the thread inside, and then you can cover that up with a rosette to make it look nice and neat. Again, a whole load of different designs and options for rosettes. The one in the middle is showing a guard. So again, guards can be used where accidental damage is likely. So I have seen them installed in schools, for example, but also gyms, for example, in schools would be a good place to put them. things like prisons, for example, would have those kind of guards, but also sort of industrial locations where things are getting moved about on a regular basis. A guard is going to offer you a little bit of extra protection to stop that head being knocked. Also, on top of that guard, we have a shield. So that particular product there is advertised as a guard and a shield. So that the shield is there to stop any water from above, again, affecting that sprinkler head. That's why it's kind of got a little umbrella on the top. It is we want the heat from the fire to kind of come up and activate that head. We don't want things from above to affect the temperature of that bulb. That's why it's got a little umbrella on top. The one on the right, is that a guard or is it a baffle? Answers on a postcard. In terms of 12845, our code standards, it doesn't mention the word baffle in there at all. So for me, that would still be a shield. So that is to stop the water coming in from above. But other people kind of seem to use the term baffles, and I have kind of seen information about them being used almost to kind of catch the heat from below. So if you've got, if the heads are kind of a long way from the ceiling, where the heat comes up from below and rises up, that baffle is going to kind of catch the heat to set off the sprinkler heads. So as far as I know, that is not something that we do in the UK. That's not something that's covered by our code standards, but it does seem to be a thing. There is some information out there, but I think for us, it's very rare that you would ever get that kind of situation. We want the heads to be close to the ceiling, so that any heat is going to be sort of caught by the ceiling and then sort of come down to activate the sprinkler heads. But we can use shields to stop any heads located above kind of wetting and interfering with the heads below. I'm not going to go into much detail on these, just to let you know that they exist. So Annex N and Annex P of 12845 talk about other types of sprinkler head. So CMSA sprinkler heads, control mode specific application sprinklers, aka large drop sprinklers, and ESFR sprinkler heads, early suppression fast response. So both of these heads are designed for kind of warehouses, storage risks, where you're protecting particularly flammable materials. And the idea being with both of them really is you've got a high volume of water being discharged over a short amount of time. So again, just really to let you know that that there are these kind of special types of heads available. But yeah, it's unlikely you're going to see them outside of a kind of a warehouse environment. Choosing specifying sprinkler heads. So I haven't got anything to kind of show you on this slide. It's really just a reminder for me to talk to you about choosing and specifying sprinkler heads. So as you can see, there is quite a lot to think about. So what I would suggest is if you are a specifier, then you need to work with the sprinkler contractor, because I imagine you'll be coming at it from different points of view. Obviously, you both want a head which is going to be approved and suitable for the application. The contractor is likely to want to use the heads that they've always used, because that's kind of their comfort zone really. They've used heads before, they know that they work, and they've got them on a good price, obviously from their distributor, because they're buying them in bulk. So they'll be saying, well, here's some options. What about this one or this one? So at the other end of the scale, there's probably going to be building owners, specifiers that are looking more to the finishes and the aesthetic, and you can be saying, okay, well, what about this head and what about this head? So you really just got to come together and say work out a head which is going to be suitable for the application. It's going to be kind of easy, quick to install, just kind of covering getting everything on the table really. I don't think that the sprinkler contractor should be saying, it's this head or nothing. And equally, I don't think that the consultant, for example, should be saying, I want this head and only this head. It needs to be a discussion to make sure that an appropriate head is chosen, which also meets any other criteria that the building owner occupier may have. Okay, so that's it for Sprinkler Talk 18. Next week, we're going to be looking at installations and zones. So this is looking at the maximum sizes of any installation, why we zone, how we zone sprinkler systems, and again, what are the limitations? How many zones do I need per floor? How many zones do I need in a kind of an airport example, for say? In terms of a large flat area or a tall thin area, how does the installations and the zones work? So I'm going to begin going through that with you in detail next week. Okie dokie. So I will just hang on and see if there's any questions in the chat. And again, just let me know if there's anything that I've missed about sprinkler heads. And I can cover that maybe in a future episode or drop it in as and when. But again, thanks a lot for listening, and I will speak to you again soon. Bye bye.